Alright, so welcome to the guide. This video is going to be going over some of the documentation that we have right here, as well as going over the actual workflow for taking these scanned assets and turning them into your game assets. So I'm going to just do a quick read through of this document, and I'm going to go over the basic process of scanning. Um, but in terms of the actual scanning itself, um, I won't be doing a live demo of that here today. I'll just be going over the basic process. There's plenty of documentation for that. It's a full guide here in text, so if you're trying to get the step-by-step guide, just read through this document, uh, go through the documentation that's provided in this document as well. You should be able to get your scanned asset finished and exported. This video is mainly going to be showing you how to create the game-ready version of that scanned asset. So let's get into it. So just start off with some disclaimers, limitations. This workflow goes over the process of scanning an object using the Creality Raptor that we have in the GIMM lab and processing that scan into a game-ready asset. And the thing about that is this workflow does not teach you how to turn scanned assets into animated or rigged assets, because we are mainly focusing today on creating static objects that will exist in your environment. So taking scans of individual props or different elements of your environment that are not going to be moving or bending or animating. If you want to take scanned assets and turn them into those animated ones, you'll need to do a manual retopology workflow, which there are many different ways of doing that. I recommend looking up ways of doing that, but today we're going to be doing a automatic retopology because we do not care about our asset deforming or bending or animating in any way. We just want it to look nice and be performant for our game. So just wanted to get that quickly out of the way. If you want to do that sort of thing, then yeah, look that up. So getting started, there's a few software that you should already install before even getting started. The main ones are Creality Scan 4, which is the software that interacts with the scanner itself. Blender 4.4 or higher. The example Blender project that I have in the drive that is provided to you is based on Blender 4.4, so it cannot downgrade. So if you do not have 0.4, now's the time to download that or go higher. I can't speak for if this will work in future versions of Blender, but it could definitely work in 4.4. And the last one is the Instant Meshes app, and that's going to take you to a GitHub. If you don't know how to install things from GitHub, it kind of varies from project to project, but for this one, scroll down here to the pre-compiled binaries and simply download the one that is for your platform. In my case, that is Windows. It's going to give you a zip file. You're going to unzip that. Then you can just open that, and it will give you Instant Meshes, this application right here. So yeah, those are the three that you need for this workflow. These are all free. I did not include any paid add-ons or paid software in this, so it can be as accessible as possible. There are ways of doing this all just in Blender and Creality Scan, but those are using paid add-ons. So I did not include that here, but if you have those things, then feel free to use them, and you can skip over the Instant Meshes part. But Instant Meshes is honestly one of the best ones that I've seen. So even if you have a paid one, I'd give this a shot just in case you like it. All right, so scanning your asset. To begin, when you open Creality Scan, you are going to be met with this screen where you need to choose which scanner you're going to be using. In our case, we are using the Raptor, so you're going to go ahead and click on the Raptor series, and it's going to give you the breakdown on how to connect it, how to interface with it, and the basics of the scanner itself. This scanner has a blue laser mode and an infrared mode. And the primary difference between those two things is that The blue laser mode is really useful for high accuracy, high detail scanning, but it requires using the circular markers for assistance in that, because the markers, basically what they do, they're these little stickers. So you can see them if you open up the scanner. In that box, there will be these little dots, these little sticker dots that you can stick all over things, and those are basically markers that tell the scanner where those points are, and so it can use that data to connect the point cloud that it's creating together. The infrared mode does not require those dots. You can try that out, but for the purpose of this workflow, we want as high accuracy of a scan as possible. And so I went for the blue laser mode. The infrared mode is good for fast scanning. It's good for if you don't have the stickers. It's good for if you're just trying to like really quickly scan something. And the infrared mode should work for you, but I cannot speak to how good the scan will be. That is going to be up to your trial and error. But in both cases, you will be able to texture your objects using each scan mode, using the built-in camera on the scanner. It will automatically pick up any color data, and so you will get automatic textures, just like what you see right here with this cool little statue. You can see all the colors, details are coming through there. So that's really cool. You don't have to do any manual texturing yourself. And it's just going to give you some basics on how to do all of that. It's going to go over exposure settings, what is ideal for your exposure, and the basic workflow of how the software works. So when you begin, you're going to create a new project, create a new scan, as it says right here. You will need to calibrate your scanner beforehand so that it works. When you have your scanner plugged in, you'll see a little option here on the top left. You see where it says scanner disconnected for me. It will have an option for you to calibrate it, and you will need to place your calibration plate on a flat surface and go through the whole calibration process. It goes over all of that with you as you're doing it, so I don't need to explain that in detail here. I do explain it in detail in the document though, so you can use that to help assist you. Once you calibrate it, you can go ahead and scan your object by placing all sorts of the markers in the area around it, like so. See how there's all these markers around it? You don't want these markers to move at all. You never want the object itself to move while you're scanning it, so don't move it. You only want to move the object in between scans, so you can scan the top and sides of this toy gun, for instance, and then you would flip it around and do a new scan. The kind of scan we're going to be doing is point cloud scans. If your object is very large, you may need to place the markers directly onto it and do a global marker scan so that you can mark where each marker is. I said mark a bunch of times right there, but you get the point, so that you can have those point references and then go into a point cloud scan afterwards. So this goes over the scanning pipeline, and we have a pretty basic workflow of scanning, fusion, meshing, mesh editing, and texturing. And for the multi-scan, it's just a matter of going between individual scans and fusing them, and then moving on to the next one. And yeah, I mean, just go over this this entire document right here. It'll teach you how to do it, as well as in the software itself. If you go to the user guide, there is a tutorial for the software on how to use it, but the basic process is just scanning, turning it into a higher quality point cloud, meshing it, which means turning that from a point cloud into a mesh, editing that mesh, cutting out any parts of it that you don't want. A lot of times when you're scanning your mesh, you're going to get parts of the table or surface that you are scanning on top of. So you can lasso that and delete it, edit that out. And when you're finally happy with the final mesh, then adding all the texture data on top of it. And they make this really simple for you. It's just They even have a one button processing option, but typically I like to just do it manually. But yeah, once you have all of that done, you are then going to export your final mesh and you are going to import it into Blender. So for this step, the main thing that you're going to want to do, let me just give me a moment, is go ahead and drag your exported object into your viewport and drop it. Having some issues. If you're having any issues with the... there we go. I was dragging the wrong file. So yeah, you're just going to drag the .obj file that was exported from Creality into here. You shouldn't need to change any of this because the very nature of the scanner means that the scale will be accurate already. And then you're going to click import. So when you import this, this is a very high poly mesh. In fact, if I go to here, I can actually see the statistics, which will show me that this mesh that I have right here is 2.5 million triangles. Now, the primary issue with this for a game, even though it looks really nice here in Blender, is that if you were populating an entire game with these assets, it would make your game run very slow, and it would also have memory issues. Your game would be very, very large because the meshes that you are using have a lot of data to them. So our problem here needs to be solved by lowering the resolution of our mesh and baking all those details down onto that lower poly mesh. So I'm going to navigate through here. Another thing is that for this guide, I even say this in the disclaimers part of the document, you are expected to know how to use Blender at a basic level. You don't need to be a very proficient modeler, or we're not going to be doing any modeling in this. You need to know how to navigate, panning and, clicking on buttons and different menus and stuff. I'm going to go through all of this as I'm doing it, so I'm going to be very vocal about what I'm clicking on, why I'm clicking on it. But a basic understanding of how to navigate through Blender is going to be very important to follow along here, so keep that in mind. But yeah, so we have our mesh here. We can see that's actually very off-center. The center is right here, and the mesh is both upside down and off-center, and I want to fix that. So the first thing I'm actually going to do is I'm going to see, okay, if I scale this, so it's using the center as its scale. So what I'm going to do actually is I'm going to make sure that I have this thing selected, and I'm going to click on Object up here at the top. And I'm going to set the origin to the geometry. What that's going to do is it's going to make the center of this object the actual center of all of the mesh data. So if I scale this, for example, if I try to scale this, it's scaling from the middle, and it means the pivot point is in the very center, which is what we want. So now what I'm going to do is I'm going to do the Shift S command. That's going to open up this pie right here. And I'm going to click on Selection to Cursor. And that's just going to bring my mesh here to the center, which is what we want. I'm going to go into a head-on view of this object by pressing 1. You may need to press that on your number pad on your keyboard. And we can see here that the object is not facing the right way. So I'm going to press R to go into rotation mode. And I'm going to find whichever axis I want to do. I think Z should be good here. You can see the blue line. I want to update this so that it's rotated to face the camera. So 90 degrees should be good. If I just type in 90, it did that. And it's facing the camera, not all the way though. I'm going to click on R again to rotate it, Z, and I'm just going to try to rotate it so that it's facing the camera head on. There we go. From here, I can just do rotate 180 to rotate it on the axis that I'm facing. And Let's rotate it a little bit more so that it's facing the right side up. Great. Okay. So now, if I pan around, if I want to see from the front again, I can press 1. If I want to see it from the side, I can press 3. This is what we want relatively. I'm actually, from the side view, I'm going to rotate this a little so that it faces like that. So I'm actually going to, first of all, I'm going to do Control A. I'm going to apply all transforms. And then I'm simply going to leave that for now, but later on I think I might move this so that the pivot point is near the feet. Alright, so now that we have our object here, this is going to be our high poly object. So I'm actually going to go up here, click on this just to make sure that the material got brought along with it, and it did, which is great. If it didn't, then you may need to go down here to the material properties and double check that it has its material. If it doesn't, you can go up here to the shading tab, and it's going to open up this menu here. In your material, it may just be like a regular principled BSTF like this. What you can do if you just want this texture to be attributed to this is that you could go into your files, drag your texture into this window, and simply connect the color to the base color, and you will get exactly the same thing that I have here. Okay, so we have our high poly object here. It's still very high poly. I'm going to quickly rename this to whatever this object name is underscore high. This is our naming convention. So I'm going to call this dinosaur underscore high. This just lets us know that, hey, this object is our high poly version of our dinosaur that we will use to bake the details down. If I go here to this little wrench icon, that's our modifiers. If I add this modifier, I'm going to try out a decimate. This is just for example, by the way, you don't need to follow along here. But a lot of the time, when you're trying to lower down the poly count on an object, you might try to use a decimate modifier. Simply set this to a low value. And this is going to make my computer slow down. Give me a moment. All right. So we have the lower poly version here. It says our face count is still really high. So I could lower that even more if I wanted to. Maybe like 0.01. That's a little better. And you can see we keep going lower and lower. But the problem with this is that we lose all the detail, which is good, but the problem is that we have all these little lumps here, and we would have to go through this and manually do a lot of fixing here. And overall, it's just not a very clean way of doing it. You can do it this way. I've done it this way before in the past, but I personally prefer using instant meshes. So what we're going to do is we're going to export this object into instant meshes now that we have fixed its pivot, and you're going to edit it in there. So again, make sure your object is selected. It's highlighted like this. Go up here to File, Export as an OBJ. And simply save it as selection only. And nothing else here should really need to be clicked on. Name your object the same as you have here, and click on Export. I've already done this, so I don't need to do it again. All right, now once that's done, I'm going to go ahead and open up Instant Meshes here. And this software is really great. It basically lets you take a really high poly mesh and turn it into a nice simplified low poly version of it automatically. So go ahead and open up your mesh here. All right. Now you can see here we have our object. You can left click to rotate, right click to pan, and that should be good enough for now. All right. So I want to make this object pretty low, like somewhere in the 1.5, 1.7 thousand vertex count range. And we're going to remesh its quads, keep all of this the same. And we are simply going to click on solve right here. And it's going to give us this basic wireframe. We're going to click on solve under position field. And this is now showing us what our topology is going to look like on our object. You can see he's actually done a really good job of following the curves of our object here, except for a couple places. You can see right here we have a little bit of a problem going on here with it not following exactly. So what I'm going to do is I'm going to go ahead and click on the comb icon right here, and I am going to drag along this curve, and it's going to resolve that. And now I'm going to click on solve again under position field, and it is simply going to adjust the mesh that it follows this curve more exactly. And you can just keep doing that to all the different parts of the object that you want to fix. And once you are done with that, you can simply click on export mesh and re-export that as a low poly and put that back into Blender for the next step. One more step I forgot to mention here. When you're clicking on export mesh, make sure to click on extract mesh and then save. Alright, so the next thing we gotta do with this mesh is I'm gonna go ahead and hide the high poly. I just want to look at the low for now. And what we can do here is we can just have a look here at our low. I'm going to create a new window here. I'm going to go up here to the top right and kind of drag out. If it says join areas, you're not quite getting it. You want it to sort of split off like that. So if it says join areas, don't release left click, just right click and try again. It can be a little weird sometimes. Do that again. And I'm going to open up right here. I'm going to open up the, let's see, the shader editor. And right up here, I'm going to open the UV editor. So what we're going to do here is we're going to create some new UVs for this object. So I'm going to click on my low poly, make sure it's selected. I'm going to press tab to go into edit mode. You can also go up here and click on edit mode that way. I'm going to press A to select everything. Then I'm going to press U to go into the UV mapping. And I'm going to click on UV Smart Project. Let's just press unwrap, and that will unwrap the object so that we can put new textures onto it. Because when we create our new object in Instant Meshes, it doesn't save the old UVs, unfortunately, so we can make our own. Alright, so now that we've done this, we're going to go ahead and leave edit mode again by either going up here and switching it over to object mode, or just pressing tab will take you back into object mode. So what we're going to do now is we are going to, give me just a moment here, we are going to open up our baking settings. So just remind myself where this is. That's right. Okay. So right here in our render tab, I'm going to open that up and go down to bake. And we are going to do a selected to active bake. For our bake type, we're going to just do diffuse because we only need our color. And we are just going to disable all the lighting except for the color. So next I'm going to unhide my high poly, and we are going to make sure that the image here is selected because we need to know where we're baking from. Then let's go back to our low poly. Let's create our own new material for that. And I'm going to drag off a base color and search for image texture color. Add that in. And we're going to create a new image, just call that dinosaur. I'll make it just 1024 by 1024. And then again, just make sure that this image texture is selected. And for our last step, we are going to click on the high poly and then shift click on the low poly. Might have a little difficulty doing this. There we go. And then simply click bake. All right. So now let's have a look. Hide the high poly. Have a look at the low poly. And you can see that we have now baked our color down onto it. I click on this and I click on shades, right click and shade smooth. Unclick keep sharp edges. You can see that we have a lot of this fixed, and this looks horrible. All right, so after some tweaking, I got this to look a lot better. Basically what I did was I went back into instant meshes and I simply increased the vertex count a little bit, and I re-exported that mesh out so that a lot of the finer details could still be captured. This is still a little bit on the higher end of poly count, but that is okay. These are scan meshes after all, so they are going to be a little heavier in general. But this is still much better for a game than the other one was. And then the other big thing that I did was that under selected to active, I simply increased the extrusion distance of the baking. And basically what that did was it allowed the lower poly object to catch more of the high poly object's color. And so you can see that had a much better, much nicer effect on the bake overall. And you can see that if I go back into the wireframe mode, this is our low poly object, and it looks pretty dang similar to our high poly. Which is great. Another thing you could do is you could do the exact same thing, exact same process as the color with the normal. So you would create a new image, plug that into the normal, and change this bake from diffuse to, I believe there is a normal option. Yes, there's a normal option right here. So you could do the exact same thing again. All right, one last thing. So any images you create here for your textures do not get saved automatically. So you need to go up here to Image and click on Save and save that somewhere on your computer so that you can keep using that image once you close Blender. Because if you close Blender, it'll go away. Yeah, so that's just one less thing to worry about, but once it's done, it's done. But yeah, that's the basics of how you bake down your color details from your high to your low object. And I think we did a pretty darn good job.